So, Jason, we all know, you and I have covered extensively on this show, that the quantum computers are going to be able to crack RSA and ECC. So why don't we solve this problem by just making the keys bigger?
We've done that before.
Right.
Right. During times when algorithms were getting close to being considered weak, close to being deprecated, it was like, okay, NIST decided let's just up the key lengths and away we go.
Yep.
And there were some costs to that, but computer systems were also advancing, and so that was no problem. Mm-hmm. And I can't tell you the number of people who said to me, well, why don't we just do this again with quantum?
Yeah.
In other words, I don't want to go to MLDSA.
Sensible question.
It's a very sensible question. Short take. Mm-hmm. If you increased the bit length to the size that was enough for Shor's algorithm to fail, that bit length would be so large you couldn't do anything with it.
Right. Yep. That's the gist of it.
That's the short take.
Because the amount of acceleration is so ridiculous. It's kind of depends on the specifics of the circumstances, I think, but think something that's more than 10 orders of magnitude.
Absolutely. And the way to say that arithmetically in a simple way is the bit length being an exponential increase is not nearly as large as the polynomial increase of speed that a quantum computer is giving Shor's algorithm.
Right.
And that is fundamentally the problem.
Yes.
So therefore, I guess if you want to put it in the most simple English terms is this. It's not about taking our current locks on our doors and making them a bit beefier. It's about, we need new locks, Tim.
Right, yes. And then I think it's further complicated, isn't it, Jay? And correct me if I'm wrong on this. The more qubits you have, the worse the problem becomes. So even though we are, looking at a certain number of qubits that we're going to call cryptographically relevant, we're not going to stop. That's the number of available qubits isn't just going to stop there. It's going to continue to grow and grow. And the more qubits you have, this theoretically already too large number of, size of an RSA key you would need to have, just that itself gets bigger and bigger and bigger.
100%.
Yeah.
Oh, in fact, it's so true. You can explain it from a number theory standpoint, which is directly related to what you just said, which is, and we talked about how Shor's algorithm actually works, which is if you have a sufficient number of stable qubits, you can look at a sufficiently much larger portion of number space. And so if your key lengths are humongous, which means you're using extremely large number space, well, whatever. Just more stable qubits will take care of that.
Exactly. Yep. So there we are. So therefore, can't increase the size of your RSA. ECC is the same problem. And therefore, that's why we've gone through everything we've gone through to have an entirely new set of algorithms.
Great question. Short, simple answer.
All right. This has been Rick Causes.